Good morning, good afternoon. Hello to all of you, and welcome to the second day of the Spectrum Summit, a joint EUROCAE RTCA event. We've seen yesterday already some great discussions on lessons learned from the C-band 5G rollout and the conflicting messages reported in the press, and how can we move forward with different industries. Situational awareness in a changing regulatory environment, noting that aviation spectrum is regulated by both aviation and telecommunication authorities. And in the third session, we looked at the need for adaptation and acceleration of the avionics lifecycle, taking advantage of new and innovative technology to bring the life cycles down. Today, our program will feature a keynote from the European Commission. Then we'll look at future spectrum needs and applications, how standards can evolve to meet future needs, and finally, working together on spectrum. How can we help? What's next? But before we go into this, just some housekeeping matters. Today's live stream broadcast will be available for viewing on the EventMobi platform later today on the main stage Day 2 app. The content is available there for viewing until December 21st, so 1 week. And then in early January, all content will be made available on our respective YouTube channels and will notify you when it's posted there. The sessions from yesterday are already online on EventMobi, so if you missed it, it's a great chance to catch up. A reminder also that we have a pre-recorded session, which is setting a bit the stage for current controversies of spectrum use. This is available in the platform. When you click on the agenda tab, click on the pre-recorded session. It's a 26-minute overview, which includes a background on radio spectrum and how aviation uses it, how spectrum is allocated at the national level, the international organizations involved in allocation, and some more. It's a really good overview, very informative, and if you want to, all you need to know about spectrum in half an hour or less than half an hour. We've also posted a document on the event platform called Spectrum Compatibility Resources. This document includes links to a white paper, webinars, and an update on the work from RTCA special committees and EUROCAE working groups on spectrum. It also explains how you can get involved in our work and how you can contribute. EUROCAE and RTCA details on who we are and how to get in touch with us are also available online under the Companies tab, so please feel free to have a look at that. You can submit questions for our panelists by typing into the field on the Q&A section of the main stage Day 2 tab. You can see that on the screen right now. And if you have any questions, please feel free to do that. If you'd like a copy of the slides from today's sessions or also yesterday's, feel free to email us at membership@rtca.org. And finally, we'd like your feedback on today's and yesterday's sessions, what you'd like to hear from us in the future. So at the end of the event, please make sure you visit the Polls and Surveys tab to answer a short survey there. But without further ado, I would like to thank our sponsors, Alpa and Garmin, who really make this event possible. Thank you very much to both of you. Without further ado, I'd like to go over and introduce Paco Salabert from the European Commission. Paco will tell us about the policy level actions coming from the CNS Advisory Group, which was created by the European Commission, looking at how regulatory and policy tools could be used to ensure the CNS infrastructure needed to support a future operational concept can evolve in a more efficient and timely manner. Spectrum is at the center of the discussions in this regard. And the group developed a report that provides recommendations and an action plan to be implemented by the stakeholders. But Paco will give us a little bit more on the recommendations of this study. So Paco, welcome, and over to you.
Hello, good morning, good afternoon. First of all, I would like to thank RTCA and EUROCAE to invite me to participate in this global summit on a spectrum that demonstrates the spectrum of the importance of a spectrum in ATM. But why a spectrum is important? I will say that there is no air traffic management service without CNS services, and there are no CNS services without a spectrum. A spectrum is as important as having avionics, terrestrial systems, or satellites to provide CNS services. In my briefing, I'm going to talk about what the European Commission is doing on the use of a spectrum by aviation. But before starting, let me present how the European Commission is organized to set policies and harmonize regulations on the use of a spectrum in aviation across 27 member states of the European Union. This maybe is useful in particular for those colleagues in the US and other regions that are not familiar on how we are organized in Europe. So in Europe, in the European Commission, there are 2 directorate generals involved in a spectrum that are somehow equivalent to ministries at national level. So we have DG Move, where I work for, that is in charge of transport policies, including aviation, and DG Connect, that is involved in the setting the policies for spectrum and interface with the telecom industries. So in DG Move, we are in charge of establishing policies for aviation, including ATM, and their implementation in close coordination with our agencies and bodies like EASA, the Eurocontrol Network Manager, the CESA Joint Undertaking, the CESA Deployment Manager. We have a cooperation partnership with Eurocai, and we are the interface of the Commission with ICAO. DG Connect is in charge of setting a spectrum policy and regulations in an harmonized way and in coordination with the spectrum regulatory authorities at national level in 27 states. So DG Connect, it's the interface of the Commission with ITU and its European region group called the CEPT and its Electronics Communication Committee. So we have a very fluent relationship and fruitful cooperation between DG Connect and DG Move. So we are connected and in close, having meetings and iterations every week. And just to give you 2 examples of the things that we are doing in cooperation inside the Commission is to facilitate the cooperation between the telecom industry and aviation industry to achieve that the future and current regulations on the use of 5G will enable a safe coexistence with radio altimeters. So we are engaged in all the discussions of the group that is run by ECC called PT1, that is working on the safe coexistence of 5G and radio altimeters, and to coordinate with DG Connect, who is preparing their new regulations for the upcoming use of 5G in other bands. Another area of cooperation that we have between DG Move and DG Connect is that we are coordinating to prepare the position of the European Council to the World Radio Conference 23 that is upcoming next year. And we are taking into account what is the position of ICAO and what can be promoted as part of the EU policies in aviation. So these are the things that we are working here. We think that it's extremely important that we have a communication at regulatory and policy level between the 2 DGs of the Commission that are working on a spectrum on aviation. But then after this introduction, next slide, please. I want to develop further what Anna has explained. So in DG Move, we established a group of experts 2 years ago involving different organizations, EDA, so that means the military, EASA, Eurocai, Eurocontrol Network Manager, CESA Deployment Manager and CESA Joint Undertaking, and also bring the stakeholders that are implementing CNS. SP users, we have representative from IATA, ANSPID represented by CANSO. We have also EBAA, the Airports Council International, and also representation from the professional staff organization. So we have been working 2 years on defining recommendations to improve the CNS implementation. First, identifying what is the problem statement, what are the problems that we are facing in the CNS implementation, looking forward for solutions and actions to implement the 12 recommendations. I'm just going to focus on the 3 actions that we identified in the CNS report and action plan on spectrum that are presented in the next slides. Please, next slide, please. So the first action that we have agreed is to protect availability of the spectrum for aviation and ITU, considering global interoperability. So our objective, and it's part of the coordination that we have with the stakeholders and DG Connect, is to align the European positions at WRCs with the aviation needs, to define a policy level objectives for radio spectrum needs to support safety services, and to define susceptibility levels for CNS technologies to protect existing services from out-of-band interference. So on this action that we are proposing for, that we already have started, that we propose to strengthen in the future, we want to take advantage of the lessons learned on the safe coexistence between 5G and radio altimeter, the GNSS interference, that is a subject that we want to bring to the next conference in WRC23, and also to take into account that the military users in aviation are also users of the spectrum, and we want to create a stronger synergy at the national level and European level to support the aviation interest on spectrum matters. Next slide. The more long-term objective as part of the second action that we have agreed is to develop a long-term European Union strategy for aviation in compliance with the relevant legislation that is prepared by both DG Connect and DG Move to improve aviation spectrum efficiency. There are different objectives of this action. As mentioned before, we want to protect the aviation remaining spectrum, to define criteria to protect the system components from harmful interference from other ITU services. But it's also what is important is that we have the policy objective to transition to a new generation of CNS systems that are going to be more spectrum efficient, and we will favor the deployment of systems that are spectrum efficient, and we will promote also the decommissioning of CNS systems that are less spectrum efficient. So the Commission, the European stakeholders, states including the military, are going to be part of the taking part on the preparation and approval of this strategy that we will have to develop in close coordination with our colleagues from DG Connect that are interfacing with the telecom industry. We will not start from scratch. We are going to take into account the work that has been already done in CESAR, in ICAO, in terms of the strategies. We want to apply an integrated CNSS with two S's because it's combining the S as an additional infrastructure of the spectrum for CNS. So we want to have an integrated approach where spectrum is a key element of the evolution. And as I mentioned, this is something that we cannot do alone in aviation. We want this to be an EU strategy, combining the needs of the telecom industry and the aviation industry. And third slide, I mentioned that the spectrum efficiency should be a driver for the future evolution of CNS systems in Europe, but we need to define first what spectrum efficiency means. And then we have this action with two objectives: to define a methodology to assess the aviation spectrum efficiency, considering best practices in other industries, like in the telecom industries. And we have already some examples in CESAR of systems that has been based on the 4G technology that can be applied in aviation, and introduce spectrum efficiency as a key element for the future CNS evolution plan. So the responsible of this action is going to be the CESAR 3 joint undertaking and the future CNS program manager that will be in charge of preparing the CNS evolution plan. And in the action plan, we have identified that the work of the EuroCAE Working Group 124 and the RTCA Steering Committee 242 as one of the main bodies to provide guidance and inputs to undertake this action to ensure that the radio frequency characteristics of CNS systems use the spectrum efficiently. So that's the third action that we have agreed in the action plan that will help us to define the policy level activities and in close coordination between the DG Connect and DG Move. So that's it. These documents are available. If you are interested, I can share this information for those in particular in the US that are not familiar with the work of the CNS Advisory Group. But to finalize, I would like just to thank again for this opportunity to share these activities at more policy level in Europe. I hope the discussion of this summit will help to increase awareness within and outside the aviation community about the importance of a spectrum for aviation, to facilitate a fruitful cooperation with other industries, in particular with the telecom industry that are our neighbors in terms of use of radio spectrum. So that's it. Many thanks for your attention, and I'm ready to take any questions if there is any on my briefing. Thank you. Anna, back to you.
Thank you very much, Paco. Quite a comprehensive approach that the European Commission has set up there with the CNS Advisory Group, clear actions and responsibilities that we see coming out of it, and a clear role also identified for the standardization organizations for sure. And I'm sure that we can put the link to the reports onto our platform and include that in the post event material. I don't see any questions, so moving on to our next session. Our next session will look at spectrum needs and applications, future spectrum needs and applications. New entrants come in to push the boundaries in existing industries. There's a greater demand for spectrum to enable operations. Existing spectrum users therefore need to make room to expand bandwidth to allow for innovation, but that brings particular challenges for all stakeholders, industry, regulators, operators. This is what Laurent will discuss with his panelists. Laurent is a senior expert for navigation systems at Airbus and also a long-standing member of the EUROCAE Technical Advisory Committee. Over to you, Laurent.
Thank you very much, Anna. Well, welcome. Good morning, good afternoon, everyone. I'm very pleased to be with you today to moderate this session, very important session. Well, just a few remarks in a few seconds. As a representative of the civil air transport, and you heard that yesterday, we are all facing the introduction of new telecommunication services, and we need to adapt, for instance, for the 5G C-band for radio altimeter. But at the same time, we should also think about the future and welcome new entrants, new applications, and new services. And so some of the keywords about that are adaptability, efficiency, obviously safety, but also collaboration with telecommunication and coexistence. And today I have a great team of panelists that will introduce us to the future spectrum needs and applications. So first of all, I would like to introduce Gary Bertz from Eurocontrol, Boris Resnick from Flyversity, and Davis Hackenberg from NASA. And so this team of panelists will introduce you their views on the future spectrum needs, and then we'll go to a short, small debate and some Q&A. So, Gary, back to you. I leave you the floor to introduce the subject. Thank you.
Yeah, thank you, Laurent. Hello, everyone. You did mention the radio altimeter. I hear that was also a big topic yesterday. One of the, let's say, few good things that come out of the debate is that the topic all of a sudden caught senior level attention. So all of a sudden I had our Director General of Eurocontrol actually ask for a paper on spectrum. As that, we tried to set things into perspective between the telecoms and aviation industry. And when you see in this table the global spectrum allocation, we are actually quite similar in size, using a bit over 2 gigahertz of spectrum. The telecom colleagues, many of them are saying, look, almost every other industry has given spectrum to us for telecoms. Why haven't you? Now, if we look at the size of our industry within about 3 dBs, we're roughly the same size. You will see that tax revenues generated are a bit higher on the telecom side. And you'll have to add on top of that money made in spectrum auctions, the revenue from those auctions. So we asked ourselves, is aviation really innovative and able to innovate? And the answer is yes, very much so. But this is primarily the case when you talk about new engine, more fuel efficient engines, better airfoils, etc. When it comes to CNS equipment, you need to look to the market makeup. And there you see that telecoms has a lot of compared to avionics, relatively cheap devices that have a short life cycles, while we are stuck with a few expensive devices with a very long life cycle. And so that inherently makes it very difficult to replace CNS avionics. An interesting comparison you see on the side also about how we are represented in ITU. So unfortunately, this is a bit of a David versus Goliath fight, if I may use that expression, and that we are really not well represented, even though we are a major spectrum user. There are about 192 ITU and ICAO member states, and so we are well below one person working on spectrum per state. And if we would increase that number to one person per state on average, obviously the smaller states might have to pool resources, but the larger states should really be present in much higher numbers. And really the only positive exception here is the United States and a few European states that are present at ITU. But you all have heard the saying, you get what you pay for. In this case, aviation is getting what we're not paying for. And so to me, the question is, how much are we willing to pay to actually preserve that benefit? Next slide. So we did a think paper on that, where you will find that table. There are more details in that. But the point is that we actually have, under ITU radio regulations, not only the protection, the safety protection that is afforded to us, but we also have an obligation to apply the latest technical advances as soon as possible, which is where you quickly get into questions about, well, what is as soon as possible? To get back to what the telecom industry perceives, we did a study, contracting in particular with a telecom organization, and they said if you would use state of the art, you would do all of CNS with about 20 megahertz. That already includes some redundancy. Now, we don't actually agree with this number, but the important thing to remember here is that this is the perception of telecoms. So to try and improve, next slide, we thought about what we can do. And as you see in the radio altimeter debate, one of the most important things is that you have to do as good adjacent band filtering as possible. But when it comes to life cycles of equipment, well, what is as soon as possible per ITU radio regulation? Well, if you take an aircraft life cycle of 20, 30 years, and you have avionics that live longer than that, many of them, the ILSs, VORs, DME, VHF COM being designed 50 plus years ago, well, you have all had to update parts. You all have to deal with parts obsolescence. And if we can't even update avionics on such cycles, it is difficult to say that we are doing things as fast as possible. And then we have this other tendency where we develop new systems, but then don't manage to actually succeed in the transition. We had GBAS replace MLS, and now GBAS is struggling. We have proposals for a new telecom, for a new comm system, LDAX, that is struggling to get into the industry. Next slide. And I think this struggle is because, well, so far equipment earns its way onto the aircraft with operational benefit. But we are a mature industry, so we can pretty much do what we want. There's still a few improvements that we can do, but really to replace a piece of avionics due to spectrum as a driver is not something that we have done so far. And that's really a place where we need to get to. Not only do we have new entrants, but for example, I take the DME band. If we want to accommodate LDAX, new drone services, whatever, well, currently we suffer from congestion. So first, to actually accommodate new entrants, we need to make space, and already that needs an evolution. We also have a need for improved security in aviation. We are open system, and that too will take spectrum. So these are the drivers that need to change. where it's no longer just operational benefit, but that we need to be really more systemic and also look at how spectrum improvements can actually drive CNS innovation. Thank you.
Thank you very much, Gary. You tackle a very important point, and I'm sure it's going to drive some question. At least it raised some questions from me. So now I leave the floor to Davis Hackenberg from NASA. Davis, sorry, back to you.
Yeah, thank you. Yeah, I want to say thanks to Paco and Gary as well. Great briefings to open this up. Thanks to our TCA and EuroK. I'm Davis Hackenberg, NASA's mission manager for advanced air mobility. Had an opportunity to work with our TCA for about the last 12 years, and both their CNPC 228 work and detect and avoid, and also some time with EuroK. So we really appreciate everything that's happening there. I know NASA and all the research and aviation community is on board with what you guys are doing. Just real couple quick sentences on NASA, like in an overview sense on this topic. Obviously, I'm in the aeronautics group, but there's a lot going on at NASA with respect to spectrum, COMNAV surveillance information, even on the space side, operational space technology development, a lot of innovations always coming out of our organization, and a lot of the subject matter expertise that we dig into in the aeronautics group comes from space ops, space technologies, and even the science mission directorate. Sitting within aeronautics, we've got four main kind of like mission areas that we focus on. One of them is commercial transport, a very well-established industry, and always evolutions going on with respect to CNS. We don't have a huge CNS portfolio focused on commercial transport, but we do have a revolutionary aspect where we're always looking at new technologies. Another one, supersonic, hypersonic, so high speed, if you will. Again, not a ton in CNS going on there. At some point, I imagine if those technologies mature and enter the market, we'll have a lot to consider with respect to their operations and designs and everything. The other two are heavily CNS focused and dependent, though. Airspace and then my mission, advanced air mobility, have huge dependencies on COMNAV surveillance. So on advanced air mobility, kind of code word for emerging aviation markets, if you will. We talk about three main application domains: urban air mobility, which is really our core focus due to the high barriers to entry in that market, and some of the ways we think it'll scale. It gives us an opportunity to look at kind of the future needs of a system and maybe their maximized sense, and gives us an opportunity to optimize towards that. There's also regional air mobility and low altitude air mobility. Low altitude's another domain that is huge for COMNAV surveillance and major innovations, and all of those are within our mission. We take a really comprehensive systems engineering approach to those. So we start with ConOps documentations that really focus on the visions of those systems, where they need to go to be scalable and provide the most benefit to the most citizens in the United States specifically. Take those ConOps, derive those into top level requirements, and then build reference architectures that we can go kind of test and implement through our modeling, development, simulation, and test and demonstration environments. If you go to the next slide, please. A lot of that work has led us to where we're at today. It's a very initial architecture. The one that you're looking at here is specific to UAM. We have a complement to this for low altitude mobility, UTM, if you will, as well. And then regional mostly is leveraging a lot of the services of today and very parallel to other remotely piloted work that's going on in our TCA. But I'm going to focus on the UAM for architecture specific here for a minute. Our research portfolio is really broad. A lot of work going on the vehicle design side, so acoustics, safety, flight controls, weather tolerance, things like that. Mostly not that relevant to COMNAV surveillance and spectrum specifically. A lot of the communications done wire to wire on board the aircraft. But as we get into the rest of our research portfolio that you can see represented here around, like vehicle operations, automation, pilots, operators, things like that, huge dependencies on COMNAV surveillance. A lot of our airspace integration work. So again, that extensible traffic management started with UTM, kind of expanded out to be part of high altitude, long endurance, urban air mobility, and other environments that we think these concepts of third-party services will extend to. Vertiports, highly dependent on CNS infrastructure, for surveillance of the vertiport, for communications to aircraft, relaying messages on safety and so on and so forth. In-time aviation safety management systems, we think, are going to be a huge part of this architecture. Lots of different services that will have spectrum requirements associated with those that we're looking at. And also the community integration piece, maybe more associated with the vertiport side, but a lot of spectrum surveillance equipment that's going to need to be installed, across our urban environments to really support this aviation system long term. So again, essentially what we're doing on CNSI is taking a comprehensive look at the future of what it needs to be for advanced air mobility, and again, in this case, urban air mobility, kind of looking at this arrow by arrow, line by line, communication by communication, and understanding, how that communication, nav or surveillance is going to be performed, write requirements for that future state, assess the spectrum needs for that, and really come up with the innovative solutions that we're going to need in the future to solve these problems. Many of it, I heard Paco say earlier, no aviation without CNSI and no CNSI without spectrum. Kind of want to foot stomp that. It's huge. We have so much, as Gary said, so much going on in the spectrum and CNSIS. I like that added spectrum piece to CNSI. I'm gonna figure out what to do with that internal. But so much going on today that we can leverage. Obviously VHF has been a part of the system for a long time. Probably will stay a part of the system for a long time. But we know we're going more digital, right? So VHF there is something that someday hopefully can be more obsolete for these future digital aircraft. But many of the other technologies where there's spectrum allocated and assigned, maybe in single purpose solutions, could go through a list: GPS, DME, landing systems, ADS-B. A lot of this stuff will be part of our future system as well, we expect. But there's also a ton of new needs that this future system is going to have. Gary talked about the emerging avionics. I'm showing here kind of the PSU, provider of service for UAM, as the centerpiece to this. ATM is going to evolve, obviously, is what we're saying there. The security piece was mentioned. CNS is just such a backbone. Some of the other new things, beyond the PSU, things like V2V, pilots communicating to each other either through voice or through digital, more cooperative collision avoidance, CNPC is a huge piece. Relays, maybe in the V2V sense, but then in the air-to-ground sense, we know that for these future aviation systems to scale and to be most efficient and profitable, that automation, remotely piloted end-to-end concepts are going to be a huge part of it. So we're going to have to look through all of those requirements. Some could actually give us benefits, have us need less spectrum as we automate more. But really what the heart of this system is talking about is a info-centric digital system where more and more information is going to need to be shared and relayed and processed by human brains and computers to make this a very long-term efficient solution. So we're looking at areas where we can get new spectrum. LTE's already been mentioned, and then obviously areas where we can do less single-purpose stuff, maybe combine spectrum, be more efficient, more state-of-the-art, and we're doing that through that systematic approach that I mentioned earlier. Understanding the full set of requirements as we can see them. All of this will obviously evolve as we get great inputs from our technical communities, do research, simulations from our subject matter experts. But we plan to continue trying to find those ways to optimize this, work through our state with ITU, like it was mentioned, to make sure that we maintain the spectrum we have and get access to more spectrum where we need it. And in a lot of cases, we operate under safety critical of today. Maybe in the future that will be consistent. Maybe we'll have more where we can do things not on safety critical spectrum, and definitely for the non-safety critical stuff that aviation will need in the future. I think as our services proliferate and if it becomes more of an more urban, more of a daily practice to leverage these advanced air mobility concepts overall, I think we're going to have more of a customer user base that needs access to spectrum that isn't safety critical to do things like work on your phone on the way to work, or fly from a regional area to get and stay connected. So a lot to consider. Just kind of showing you an initial architecture, and really looking forward to continuing this conversation with all of you. Look forward to your partnerships in the future, and then any questions you have at the end of these set of presentations. Thank you.
Thank you very much, Davis. A very good overview of the capabilities, the needs, and the evolution, especially for the UAM side. So now we welcome Boris Resnik from Flyversity, who will give his words on the topic from the US UAM perspective. Boris, back to you.
Thank you, Laurent. So I'm Boris. I'm CTO for Flyversity, a company that builds unmanned traffic management services based on cellular infrastructure. And also I lead EUROCAE activities on command and control for unmanned systems. So I can speak a little bit around this. I want to focus now on a specific segment for new entrants. And these are unmanned systems, either unmanned aviation systems or urban air mobility vehicles operating in very low level airspace, doing beyond line of sight operations, and primarily in urban environments or suburban environments. This particular segment may be quite narrow in comparison to the whole aviation, as was described by other people, but the number of entrants in this airspace is expected to be much higher, probably by several orders of magnitude higher in the long term. And then this fact influences the needs of the spectrum quite significantly. So as we know, nowadays rollout of new cellular technologies such as 5G is ongoing, quite active. A lot of investment is made in 5G infrastructure and also in existing 4G infrastructure. And this is driven by non-aviation use cases. And that gives us as an unmanned aviation community an opportunity to leverage this rollout and use these networks, new networks and their new capabilities to enable urban drone flights. So here we need to emphasize that on the cellular communications, we need to understand that these are defined by 3GPP, so generated partnership, and this is generally called cellular communications. And for me, this is the primary enabler, a key technology to enable BVLOS urban air mobility operations. And there are multiple functions that we need to enable to fly over the cities, and David has touched upon this, but here I want to split this into the domains. Generally speaking, ground to aircraft communications and aircraft to aircraft communications. These are quite different in terms of spectrum needs. So for ground to aircraft communications, the primary function that is enabled by these comms is command and control, or command and control and communication, depending on the type of operations. And there may be several others, but this is the most important. As we know, ICAO produced a guidance, a new version of SARPS, that defines several aeronautical bands usable for command and control, including C-band and L-band and some number of frequencies. But these frequencies do not cover cellular communications in the sense that we do not here want any dedicated spectrum. What we really require as an unmanned community is to use already deployed networks, primarily public networks deployed by major mobile network operators. And this is a licensed spectrum, but not an aviation spectrum. And as such, it is not covered by this ICAO mandate. But as we speak about urban operations in a segregated airspace and very low-level airspace, probably the risks for unmanned systems are a little bit lower. That's not applicable for UAM, but still. The primary spectrum need here is not an allocation of new bands. The primary need here is an endorsement of aviation regulators for usage of licensed cellular spectrum owned and operated by cellular operators for aeronautical purposes, assuming that proper safety mechanisms that exist in cellular networks would be employed to protect these communications from the reliability standpoint, from security standpoint, and other aviation-based requirements. So this what I want to emphasize in regard to air-to-ground communications. From the other side, we also have other functions that are based on what we can call here air-to-aircraft communications. Sometimes these things are referred by aviation community as broadcast communications, things that are similar to ADS-B on 1090 megahertz, but probably for cellular communications, that would be more correct to call this aircraft-to-aircraft communication. And these communications would enable multiple functions. So the functions that I want to mention here is detect and avoid, cooperative detect and avoid function based on these aircraft-to-aircraft communications. And this probably may include, as Davis has mentioned pilot-to-pilot, voice, or rather digital communications, probably not voice to a less extent, but digital, and maybe other functions. But detect and avoid is the most important. For this function, there is no allocated spectrum today, and smaller unmanned system would require a dedicated broadcast band for it, because usage of things such as 1090 megahertz is not really endorsed for smaller systems. The count of them may be very significant. The number of flying vehicles simultaneously flying may be high, and that can saturate 1090 megahertz, so that is not endorsed, which is kind of well-known point nowadays. So a special band might be required. So on the contrary to ground-to-aircraft comms, the need from unmanned system in this regard would be a dedicated band for broadcast and multicast to enable these capabilities. So these are two key needs from this segment, a very specific segment, but if we talk about new entrants, this would be the most promising and most the newest segment of all, and the least explored. But here, how at least it is seen by the community, or at least how I interpret this. Over to you, Laura.
Thank you very much, Boris. And now I would like to invite all the panelists to the stage, and we can start to the debate, or at least a Q&A session. Well, I think I will start first, and of course we welcome the audience to ask any question, and that I will be glad to relay to the panelists. So Gary, you started and you mentioned and the 5G C-band situation. And before looking ahead, maybe we can learn some lesson from what happened. So what is your view on this situation? What can you learn from it? And actually, do you believe that this is something that could happen in Europe? Because currently it's a situation that is most intense in the United States, but obviously 5G C-band is deploying everywhere in the world.
Yeah, indeed. Thanks, Laurent. My answer would be is that this situation is happening in Europe already. And a lot of very good technical work is going on in the US, but the issue is really one that is global, and it's one that is difficult because here we have an avionics self-contained system. The radio altimeter only needs to be interoperable with the ground that the signal bounces off of. And a very typical case where it's difficult for aviation to complain about 5G because we're talking about compatibility issues that are 500 megahertz separated. So here's really where we have to focus on maximizing our adjacent band filtering. And it's great to have seen the avionics industry turn around and engage in this debate, and that's really what needs to happen a lot more. We had very interesting discussions when some of the radio altimeter experts started to participate in the CPT, the European Radio Regulatory Forum. And the telecom guys were using their acronyms, and us aviation guys were using our acronyms, and we're just not used to talking to each other. And to actually build mutual confidence, there's a lot of mistrust on both sides, to start a dialogue that actually tries to search a solution jointly based on the principle of reason. What I like to say is, yes, there is such a thing as reasonable filtering. Aviation needs to improve, but there's also such a thing as reasonable power level. So there we need to find a good compromise, and that is really where we need to learn to engage in each other's forums and processes, because, you know, this RTCA EUROCAE is already a big machinery that has its rules. CPT ITU is a big machinery that has its rules. And to get people to make the links is we need a lot more people that make those links.
Thank you, Gary. So, well, I would like to ask a question to Davis, because you mentioned a lot of components of the US world that seem to be very similar, but looking at the situation we face, for example, with radio altimeter, are you looking to reuse exactly the same technology or the same components, or you envisage that the CNS backbone for US UAM can be different, can differ, or maybe take the opportunity for these new entrants to evolve, because it will be, well, as a leader of new entrants, they will lead to change.
Yeah, I mean, I think the way that I'd answer that is obviously we want to come up with the best of the best for these, you know, for the solutions that we're about to, you know, build and design and over the next decade together. I think like I was kind of preaching in my talk, like I think it's really important to understand what the future of these systems needs to look like, right? And from a requirements perspective, top level, how much spectrum do you need? What functions need to, you know, have spectrum associated with them, and then take a look at what we have, and, you know, do that crosswalk, if you will. I think it's pretty obvious, though, to most of us in the technical community that there's going to be some hybrid. We're going to be able to reuse some of what we have. It works well. Why fix it if it ain't broken, right? some of that though could require optimization of the current systems we're using to add more data to them and add maybe more functions onto some of those current links we're using. In other cases, there's brand new spectrum we're probably going to need to do this. If you look at some of the non-safety requirements, like I mentioned, there's definitely going to be new things that are necessary, and that's going to require new approaches for us to look at. And you know, assessments of just the radio altimeter example is a perfect one, right? Like for the future of this, leveraging LTE as part of these systems. And then I do think personally, and I think many people in this ecosystem think that some of the spectrum like LTE is going to be a part of that architecture. I don't want to go forecast that or anything. I think, you know, you let the engineering and the research play out and come up with those ways, but you have to be thinking about those types of things now. Those are really long lead research items. I don't think that the cellular community has really put the rigor yet into designing a set of aviation compatible radios that meet the safety standards and requirements the way that we do it. Probably they're, you know, the best thing that mankind has ever seen with respect to connectivity and communications. And I mean, I'm happy with the reliability, right, as far as it goes on my phone, but that's a totally different question when you get to aviation, making sure it's safe, secure, things like that. So I think we have to look at it all. I think there's going to be definitely revolutions needed as well as evolutions needed to all of the different components of today.
Thank you, Davis. And actually, you really touched the point, and that actually raised some question also in the audience. And I will ask the question to Boris, because this is also a burning question in aviation. So how do you think that you can plan to have safety ensured, for example, for C2, C3 link, or apply the same standards that we have in aviation for UAM using cellular communication links that are, let's say, public standard and not designed to support aviation safety in the first place?
Yeah, thank you. That's an important question. And here, I need to emphasize that there is a kind of misconception about capabilities of modern cellular networks in general, and especially of 5G networks. So as for protection of the spectrum, yes, public cellular networks use protected spectrum. And actually, this spectrum is already used for safety critical applications in other verticals. As for aviation applications, there is a process of standardization going on by a cellular activity that is joint activity between EUROCAE and RTCA, and in cooperation with the activity called ACJ, Aerial Connectivity Joint Activity of GUTMA and GSMA. And this community works on establishing an aviation-grade safety requirements for cellular communications based on existing RTCA standardization, that is command and control MASPs D0377, and things like integrity, continuity, availability, latency, aviation-grade performance requirements as directed by ICAO approach of general performance-based requirements are projected to cellular communications. And here, what is important that it does cellular communications used for aviation applications. It doesn't mean that people just stick a SIM card in a modem and fly. This communications uses an isolated network segment, which is safe and secure, and in general reliable enough for command and control or any other application coming from aviation.
Thank you, Boris. Yeah, go ahead, please.
Yeah, just add one note real quick. You know, even if it's, you know, not aviation protected and everything, you know, isolated, all those are great terms. There's always backup methods, right, that can be aviation protected. And may not need as much spectrum, reliability for, you know, in a contingency situation and stuff. So there's even more to it that we, you know, we'll add on over time to leverage these new systems, I think. But great answer, Boris.
So I would like to kind of asking the same question to Gary. I mean, Gary, you are closer to the regulator, let's say, in charge of aviation safety in Europe, and you share the same view, especially when we talk about using this kind of network, not only for new entrants, but also potentially for aviation, existing aviation. What do you think, Gary?
Yeah, that's a very interesting question. And what I want to highlight also, based on what Boris and Davis said, you know, there are many things that are technically possible, and industry and universities are great at coming up with all sorts of innovative ideas. But what we continue to need is a government industry partnership. Quite often those in industry that develop stuff may not be aware of the policy implications that what they develop has. So yes, we benefit greatly from aeronautically protected spectrum band that protect the safety and regularity of flight. Now, you can achieve that also in non-aeronautical or non-safety bands, but you create a very difficult situation in front of ITU. If we have decades of spectrum defense where we say, look, we cannot use commercial spectrum because it's not safety, etc., and then all of a sudden we come and say, oh, but we can do it because by now we figured out how to do it, that opens a can of worms in a lot of other areas. So I'm not saying it can't be done, but the matter needs to be looked at and presented very carefully, because the kinds of proofs and the kinds of rigors that go behind in actually demonstrating that and defending that ITU, they're quite demanding, and we're not, in my view, dedicating enough resources to that part of it. So we like the whole innovation, new cool toys and interesting capabilities. What does it imply at the policy level when we're really expected to use less spectrum, not more? Those are important things to be addressed. And there we see that often some industry pushes ahead with some great idea at ITU, even aviation ideas. But if they don't do their homework right, they don't realize how to engage at ITU, quite often they damage the reputation of aviation in the process. And so that is something that we really need to avoid, just like we need to get used to. We used to be 20 years ago where we were the great guys that enabled people in the world to connect. We also need to start to become cautious of the fact that in terms of spectrum use, we're seen as the bad guys by some. In terms of environmental impact, we're seen as the bad guys by some. So we have to address these issues very carefully in a government-industry partnership.
So thank you, Gary. So, well, this is an important question about how to leverage the public-private partnership, and I would like to hear from Davis and Boris about how it can be actually utilized, and maybe the barriers can be broken down to ensure that we go through these barriers about spectrum. So Davis and maybe then Boris, your views, please.
I may not have fully captured the question, just implementation of public-private partnership thoughts. Is that a fair characterization?
Yeah, absolutely. Well, or if there is a need to work from a public point of view and work with the private partner, how can we work together actually to go through the barriers of spectrum that is difficult to allocate or implement?
Yeah, yeah, we have a lot of talks about that internal. So obviously, being a government agency and realizing how complex this full ecosystem is, pick any one individual use case, let alone all of them. I think in short, like, yeah, we're gonna have to formalize around all this stuff, at least on a domestic basis, country to country, with the different industry bases. I think, you know, and it's got to be more than just like set of people focused on, you know, CNS. It's got to be the industry elements that also want to implement that stuff, the aircraft OEMs, obviously the airspace providers, and then working with you know, the government agencies on implementation of that, proof of safety, proof of security, all the way through. You know, in the US, the FCC, you know, control of the spectrum and everything. It's a really complicated domain. It's also probably, arguably, maybe the domain that's caused some of the most issues over the years. So yeah, got to have them, got to start working them. I think first we have to lay out more of the high level requirements and what we're trying to accomplish out of these things. And I'm not sure in many areas of the industry that we're to that maturity level yet.
Thank you very much. So it seems that we are already running out of time, and so I will need to give back the floor to Anna and Eurocay and RTC organization. I would like to thank you for this great team of panelists, and to also to thank you to have invited me to moderate. Back to you, Anna.
Thank you very much, Laurent, and thank you also to all of the panelists. I think this is a very, very interesting discussion on how the needs and challenges of the different spectrum usages, comparisons of future visions and operations. Like we need some revolution and some evolution in this, and I think this also shows the need for more communication between all involved parties. There's a few more audience questions which have come in, so unfortunately we don't have time to address all of them, but we will do so as follow-up to the to the event, and put that onto the event Mobi and websites. Just a reminder about questions. You can submit your questions for all panels on the main stage day 2 tab. And of course, all of the sessions are recorded and will be made available on event Mobi later today and on YouTube in January. Now, turning to our next session, we will look a bit more at how standards can evolve to meet future needs. We've already heard a few times the references to the Eurocay and RTCA working group special committees. So Chris will discuss with his panelists a bit how we can be responsive to the industry needs, because in the end, we do all of the work that we do for the industry and the stakeholders. Whether there are any improvements and developments that can be considered in our standards to make the use of the spectrum more robust also from that angle. Chris is a technical fellow with the MITRE Corporation and has been chair of the RTCA Program Management Committee, the PMC, and also of ST159 on GNSS since many years. Over to you, Chris.
Okay, thank you, Anna, and good morning, good afternoon, good evening to all of our panelists and participants and attendees. This session, again, is entitled How Standards Can Evolve to Meet Future Needs. And as we've heard about over the last couple of days, RTCA and Eurocay have an activity that's been underway for about a year now to look into this. This activity is being led by a new RTCA special committee, SC242, chaired by Ed Hahn, working jointly with Eurocay's working group 124, led by John McCullough. And we're fortunate to have a lot of the leadership of this joint group here with us today. We have Ed Hahn, again, the chair of Special Committee 242. He's a senior engineer with ALPA. And we have John, who's a spectrum expert at Eurocontrol's Network Management Directorate. And they'll be joined by Subgroup 1 lead chair of this group, Andy Roy, who's the Director of Engineering Services with ASRI. He's also the chair of ICAO's Frequency Spectrum Management Panel. And then last but not least, chairing subgroup 2 of this group, we have Capucine Miel, who is a PhD from ENAC in Toulouse and currently working with Airbus. So I'll hand over at this point to Ed first, and we'll go through these folks in order here with some opening remarks before doing some question and answer. Over to you, Ed, please.
Thank you, Chris. Next slide, please. So as Chris mentioned, we are working in this new special committee and working group with EuroK and RTCA. To kind of give an overview of what the committee is trying to accomplish, I'll first start by saying that the historical purpose of standards, whether they're minimum aviation system performance standards or minimum operational performance standards, these documents are really written for, historically have been written for manufacturers. The requirements and the performance levels specified in the standards are there to meet an intended function. And I'll give an example of what that means. And that the performance requirements are also specified to mitigate hazards. So when we talk about standards, a regulator such as the Federal Aviation Administration will typically do what they call invoke the MOPS or MASPs via something called a technical standard order, which essentially tells the manufacturer exactly what they need to do in order to certify a piece of equipment. The technical standard order also specifies the level of design assurance needed to mitigate the hazards based on the what the regulator assesses the hazards associated with the intended function are. It's important to recognize that these documents are written to be the minimum performance standards needed to accomplish a given function. And this is really to preserve the manufacturer's ability to innovate within those constraints. That word innovate within the constraints is something that other industries use those same words when they speak about what they would like to do and therefore why they don't want to be constrained. So aviation in that sense is no different when it comes to the use of the spectrum. Next slide, please. So as an example of intended function, the radio altimeter is certainly a well-known topic at this point. As it's used in, for example, air transport category, category 3 auto land, that can be a landing with essentially no visibility forward when the aircraft can actually land itself without visible reference to outside. As you can imagine, this is a pretty challenging operation, and the pilot is really realistically not really able to intervene in time if, for example, an undetected malfunction of the radio altimeter system occurs. And because it's such a critical function or operation, the hazard severity has been established as catastrophic in this case, because if there is an undetected malfunction, it's likely that the aircraft will have a hard landing or other even more serious result. One of the ironies here is that because radio altimeters have been so reliable over the last 3-4 decades, the information that they provide has also become deeply integrated into other aircraft functions. And this includes things such as arming and deployment of ground spoilers, auto brakes, thrust reversers, and even in changing the handling qualities of the aircraft as it approaches the runway. So in some sense, the disruptions we're seeing now, at least in the United States, are kind of implication of the reliability that radio altimeters have historically had, and therefore it's somewhat a victim of its own success. Next example, please. So the radio altimeter, the last time the standard was revised for radio altimeters, it was 1980. As such, I've extracted the only paragraph that talks about radio performance from the MOPS, and I think, as you can see, there's not many numbers in that paragraph. The ITU, or International Telecommunications Union regulations that is referred to in this paragraph have a similar problem as MOPS, as they have not really been kept up to date. One other aspect of radio altimeters that's maybe different from the typical communications function or even navigation function is that radio altimeters are self-contained functions. They don't need to interoperate with other radio altimeters or other systems that might be located on the ground. And the main consideration is that they don't interfere with each other when you have multiple installations on an airplane. This is an example, unfortunately, of the fact that considerations for spectrum compatibility have not historically been specified. Next slide, please. So that kind of is the motivation for what SC242 and Working Group 124 are up to. Looking forward, we see that the demand for spectrum is increasing rapidly by all industries, and that aviation needs to consider spectrum compatibility as we create new and revised standards. But even then, that's a great objective. But that cell phone on the right there is a Motorola Dynatac 8000 from which was the first commercially available mobile phone, and that wasn't even sold until 1983. So the question is what should the designers of radio altimeters standards have assumed in that adjacent band, especially back in 1980, which predates even the deployment of the first cellular networks. And even now, 2 years from the auction of the C-band in the United States, aviation is still trying to nail down the exact adjacent band environment globally so that the next version of the radio altimeter MOPS can be written. And by saying nail down, I will point out that, for example, several countries do not even specify a C-band power limit for their 5G deployments. I'll hand it off to my colleague, John McAuliffe.
Thank you, Ed, and I'm grateful to RTCA and EuroK for extending their invitation to me to be part of this panel. So, taking on the baton from Ed, in order to articulate the brief that this joint committee has, I would like to circle back to the very nature of spectrum. So, next slide, please. And I think we need to be reminded from time to time that in the end of the day, radio spectrum is energy and therefore chaotic by nature. It spills over international borders. It's a well-known cliche by now, causing all sorts of issues, but it remains a hugely important and useful resource. And therefore, to impart some sort of order to this chaos, there's a number of catalog of technical and regulatory measures in place. So what I'll do next is, in linking standards in this debate, I would like to, first of all, get a couple of caveats up front, just to make it clear what we're talking about here. We are not being tasked in this joint committee to develop standards per se, but we are developing guidance for standards developers. Neither is it our intention to provide an ultimate critique of all standards out there in existence. We are, in fact, cataloging what's currently available in these documents, identifying gaps in the radio specifications with the help of with the radio experts who are participating in this committee and in other companion committees, and offering sort of plain language guidance on how to close those gaps. So with that out of the way, many of you would be wondering why I have a sort of a chart up here with one of a few of these sort of well-known automotive institutions. So bear with me on that. So the anecdotal comparison that's often drawn up with spectrum as a scarce resource is that with other scarce resources like energy. So back a few years ago, Professor Martin Cave of the UK compared coal with spectrum, calling spectrum what spectrum is to the 21st century to coal what coal was in the 20th century. I'm going to take a slightly different slant on this, with comparing spectrum in some ways with real estate. I'd like to invite you to sort of take a look at this this chart in front. So you've got a big building, lots of big open spaces, a desert. You know, spoiler alert, this is Dubai back in the 80s. So going back memory lane, as Ed did in one of his charts, nostalgically. Next, please. And next again. 1985, that was. So next, fast forward to today. Well, not quite today, but near enough. The eagle-eyed amongst you will notice that that building is still right there. A lot has gone on in the immediate surroundings. The road is still there. Noisy, chaotic, many new neighbors. There's a lot of draw on infrastructure and on resources, whether it be space, energy needs, access needs, etc. And there's a few very important parallels I'd like to draw here, and one which I'd like to make in my more recent presentations on Spectrum. And I'll transition them one by one because I'd like the audience to go away with these messages firmly in mind. Next. First is that Spectrum is a long game. Evolution takes quite a long time to happen, but when it does happen, it happens very suddenly, and that change is irreversible. Next, please. Few economical imperatives for Spectrum. It's a grand old economical game is that when demand outstrips supply, you start sharing. Guess what? You start subletting. And this is what's happening in some parts of the Spectrum bands, and aviation is no exception. It might happen in some pockets of jurisdictions, and most notably in the UK recently in the L band, but this game is coming. We just need to be prepared for it. Next, please. New neighbors have differing requirements. You can see in this picture, it's quite chaotic, but there'll be a different set of draws and needs on the local infrastructure. The local environment is key, and that's a point I'll make throughout my brief here. And last, next, please. When the environment changes, guess what, guys? The ground rules change as well. And we need to remain relevant in that new world order. One of yesterday's panelists quite rightly said, spectrum compatibility is often an insidious matter. I mean, you don't know what you don't know. And to the point that you often don't know something up until the point something actually goes wrong. And then it's too late. And this touches upon one of the key tenets of aviation, that of safety. It was brought up yesterday, and I just want to sort of take opportunity of this to sort of remind the audience that make no mistake, that remains a primary goal for the aviation stakeholders, to ensure that the use of spectrum remains efficient and safe. Next chart, please. So what do we do about this? And I mean, where do standards come in? So what is it that we're being asked to do in this joint committee? The intention here is to take sort of a step back and take a strategic view of where we're going with comms, navigation, and surveillance systems. And to me, the zeroth step, the very start, is in determining how aviation standards could, or perhaps should, evolve in order to understand where they came from. And recognizing that some of these CNS systems that sometimes we take for granted on the aircraft and equally on the ground have been there for a very, very long time. Many of them before my time in my profession, many of them before me, period. And taking a look back at what I presented in my previous chart, these standards for these CNS systems have been laid out in a very, very different spectrum neighborhood. It's key to keep this in mind. So it's important. One of the key aspects in order to transition our standards to a new world order is to keep our house in order, keep our own house in order, and present a coherent front when we discuss radio spectrum matters with other sectors. At this stage, I would like to draw a comparison, and maybe drawing on what Ben Brandt said yesterday in his presentation, that collaboration with other sectors is key. And he's dead right. But we also need to be speaking the same language. My personal insight from recent discussions with other subgroups and the Red Alt and 5G parties is that there's a lot of goodwill, but we don't always speak the same language. And we're trying to address this. So a big focus for this joint committee, and this is where Ed and I are completely aligned on the RTCA and EUROK sides, is to bridge this gap and to facilitate productive exchanges, be it with the ITU or regional groups like the CEPT. We had a We had a presentation from one of the chairs of the project teams yesterday. And this is by developing a handbook that cuts through all the complexities, cuts through the language, the acronyms that we love using in aviation, but also explaining the way we develop radio systems from a safety perspective. Make no mistake, this relies very, very heavily on resource, expert resource, spectrum experts like those gathered around this virtual table. On that point, next slide, please. So who are we? But what are we being asked to do? I will not go into the detail of this because this will be to the next distinguished panelists to speak through what each subgroup is doing. So we're a group of 45 international industry contributors. So this is heavily contribution-based, as with all the EUROK RTCA subgroups. And it relies on expertise, radio expertise. Now, looking at the lists of the panelists here in this very session, and also the list of there's a few hundred participants in this forum, we're all accounted for. It's not a lot. So we need, and one of the points made yesterday in the chat comments is that we need more people involved in spectrum in aviation. It's a point that rings very true. So we're a group of 45 international industry contributors, but boil it down to when we sort of do the work, we're probably a couple of dozen who are actually actively contributing to the development of this handbook. In terms of the highlights, yeah, the goal is to ensure that we have all CNS systems have a complete specification and protection criteria that actually fit and fit for purpose for the environment that we know about today, and projecting this also to the environment we're expecting to deal with the tomorrow and the day after tomorrow. Needless to say, the products will be a couple of guidance documents. They are not standards, but guidance documents and the reports on the characteristics for radio parameters and best practices to close these gaps. I would think I will leave this at this stage in order to give some airtime to Andy, Roy, and Capucine to take on the detail as to how we're going to go about this specifications. Thank you. Back to you.
Great, thank you, John. So from the work that we've split up to, as John alluded to there, we have subgroup 1, SG1, which is the work that I'm leading with at the moment. Next slide, please. And SG1's task is to really figure out from the start, effectively a baseline of what do we have, to put it the most simple way forward, on what then can we use with that and what has been raised from what we have already to support the guidance document and the work that will fall out from it. So we've basically begun a survey of all the RTC and EUROK documents and standards to assess what we have from a radio frequency RF perspective. And so from that, we have at the moment 78 documents that we are looking to survey from the relevant experts to understand what is in the document and what's going on. I would caveat that we've tried to keep it to active equipment. So if there is still standards that are technically active at the moment, but they're not really used in mainstream aviation anymore, we're not doing those. But from that list, we have 78 total documents we're reviewing. That's been split between the currently active special committees and working groups, i.e. those that have memberships that are working on something at the moment that are available. And we also have what we call the inactive special committees and working groups where they are not in session at the moment. There's not a formal membership. And so we've been trying to reach out to necessary experts or even ourselves in 242, 124, work on the existing standards and pull the details out from the survey. And the survey is really looking at spectrum suitability, because if you sort of take a couple of steps back and look at spectrum and the use of standards in spectrum, RTCA and EUROK standards really have the most detail possible that we can find often for many aviation systems. And that is what is needed often to do spectrum compatibility assessments within aviation or externally. And so they really do form a core basis for the information. At the same time, though, alluded to what Ed talked about at the start, they are written not for spectrum compatibility, but they're written for manufacturers to design against, build against, and test against, and obviously for civil aviation authorities to certify against. So there's a bit of a dichotomy here about asking for how suitable they are for spectrum when many of those standards were not written for a spectrum consideration at the time. So very much in the survey, we are not trying to say whether a standard is good or bad. What we are really trying to do is look for how it's defined the performance, understand how it's been done, and is there any examples that may help us in spectrum guidance? And to split that down into sort of more specific areas, really the survey looks at the radio frequency functions, so the transmit function, the receive function, if there is any antenna parameters as well that may be useful, and the installation characteristics. What is also included in the survey, which can sometimes be the more interesting component that we're after, is guidance, recommendations, or simply lessons learned from those special committees and working groups that have been involved in spectrum, or sometimes even been burnt with spectrum activities before, about what they did and why they have done that in particular roles. And a great example of this would be GPS. DO235 has a lot of material on considerations for external interference to GPS receivers. And so we're very keen to understand from Special Committee 159 and its EuroK equivalent about what they have done and what they have learned to help hopefully provide information to other special committees and working groups on best practice and what has worked and what hasn't. By the end of this, the final product from the SG1 is really not intended to provide any answers directly, but it is intended to provide a catalogue of what we have and the questions that have been raised, with the idea that can be given to SG2 and Capucine's group, which we'll come on into a second, to help inform areas that we may need to look at going forward, or things that we have seen that may be of use, rather than the group trying to effectively reinvent the wheel in certain areas that's already been experienced. So I'll hand over now to Capucine to delve into more SG2 work and how SG1 will help that.
Thank you, Andy. So as that's a good transition towards SG2. So Andy always says that SG1 is in charge of raising questions and SG2 is in charge of answering to them. So what I'd like to give you today is to provide you an insight of what we are doing right now and what we are planning to achieve. So if you go on to the next slide. So basically, the SG2 is in charge of a new guidance standard. So the idea is to propose a kind of canvas or a template to support interference assessment and interference resilience. Then this canvas will be brought up to other committees. So they will have the opportunity to appropriate the method and to adapt it to their particular system. The idea is to stay non-system specific and as much as possible non-technology dependent. We are also going to contribute to the harmonization of radio frequency parameters definitions across RTCA and EuroK. And there's plenty of recommendations that are already available within ITU, ICAO, and CPT. So the idea here is to be able to provide recommendation for new standards in case there are new signals that are coming in the way. So our starting point will be what's already inside EuroK and RTCA documentations. So there are good practices, but there's also some parameters that are missing or with definitions that are not adequate for interference assessment as they were done for performance assessment. So from Andy's survey, we are going also to have a lot of questions raised by experts. And the idea will be to try to address them, or at least to say in which direction the answer can be found. So we will base our study on already existing recommendations, so ITU, ICAO, and CPT, as I mentioned. We will also bring our expertise of radio frequency specialists. Once our guidance standard will be ready, we will be able to help other committees in order to try to help them to appropriate the methods. We will be there to help them and to answer to their questions. It will also be the opportunity to gather feedback from them and so we can start to see if there's need for a new issue by then. So if you move on to the next slide. So here you have our working plan, so a very detailed one. So for SG2, we are planning to deliver our standard by September 2024. So as there's a lot of different topics to address, we divided the work into 9 information papers that will be filled all along the way. So they are kind of all related to each other. So we decided to sequence that into 2 batches. So the first batch will be about a general description of transmitter and receiver. So for example, the first information paper will try to acknowledge the question and the RF survey from SG1 and to direct the answer towards particular information papers. Then we will have the opportunity to bring spectrum envelope. So for transmitter and for receiver, these 2 ones will be built jointly in order to ensure that they are interoperable with each other. Then we will have another paper about decision criteria. So this one will give us thresholds that should be assessed for interference assessment. The 5th one will be about interference scenarios. So in which case are we going to apply our envelope and our thresholds? And the last batch, which is highly dependent on the first one, there we are going to establish our methodology in order to put all our 5 first issue paper together and to propose a method to check if there's a risk of interference or not. We will have also a paper on measurements because we are going to ask for radio frequency parameters. And so these ones will have to be measured. So we will provide recommendations as well on that. And another quite interesting topic we are going to dig into, it's margins. So we have as objective to try to have a detailed and justified margin link budget. So this one will be quite a large task to do. And the last information paper will be about interference reduction techniques. We are willing to try to check what can we do in order to reduce the risks. And so that's all I had on my side. Just want to emphasize on what John said. We are really willing to have more volunteers. So if you have any radio frequency knowledge, please feel free to join. We will be very happy to have you on board. And so that closes my talk. So I can hand over to you, Chris.
Hey, yeah, thank you very much, Ed, John, Andy, and Capucine. You very nicely framed some of the challenges that RTCA and EUROK face with their standards work regarding spectrum, and also nicely outlined the plan that's being followed by Special Committee 242 and Working Group 124 to address these. I have a number of questions, and we have some time for questions. And I'd also encourage anyone in the audience, if you have any questions on these topics that were framed in the opening remarks, to please type those in the web tool, and we'll try and address those to the extent that we have time to. Just to start the discussion here, Ed, you had mentioned how radio altimeters are really somewhat of a unique aviation system in that they are self-contained. There's no specs on what the transmitted signals look like, or very few radio frequency requirements aside from the band. And that has led to some great challenges that our industries suffered with over the last couple of years here. In the work that the group has done so far, have you identified any other systems that have those same characteristics?
Yeah, so another one that immediately comes to mind, I think, is the weather radar. Those, again, are radar systems. They're not communicating or interoperating with any other systems other than themselves. And therefore, there's kind of a lack of specification about how the receiver ought to be designed, and other characteristics like waveform and other things like that. What we've noticed is that older standards tend to include things like receiver masks when they were implemented into a known challenging environment at the time. So for example, VOR includes a maximum level of undesired signal right at the band edge of 108 megahertz because of the well-known FM broadcast potential for interference. But aside from that, it's pretty mixed as to whether a standard would really have a specified a receiver mask.
Yeah, thank you, Ed. And it's interesting because the telecom industry has expressed an interest in creeping up into some of those mid-band frequencies used by the weather radars, so something to keep our eye on. Andy, for aviation systems that do have defined masks or at least some RF requirements, has the group made any preliminary findings on potential issues of compatibility?
So not potential issues, obviously it's very scenario dependent, but I would say one of the questions that's been raised up is with what we've been seeing recently with the various systems being talked about around aviation system spectrum is to do with defining your transmitter mask and your receiver selectivity mask. And the fundamental question that sort of seems to be coming up when we're dealing with it is how far away should you specify that? And what happens when you reach the end of that specification point and go beyond that? Is it assumed that everything can work out at that? Even though power versus distance, boiling down what spectrum compatibility is, there's always going to be a certain threshold you can, you're going to hit. And certainly, in my view, seeing what's happening now with the spectrum and the changing environment, and we've seen some suggestions being talked about of 88 dBm EIRP transmitters, which is effectively emitting over 600,000 watts of power. And if you consider an aircraft may get significantly close to that within 10 meters or so for certain aircraft operations, trying to sort of anticipate, well, maybe it's going to be higher and maybe we need to start looking further out from just the adjacent band for what we're doing. And again, in my view, we need to balance that by also maybe external regulators thinking we're maybe trying to protect too far out as well at the same time. So I think there's going to be an interesting question when we get into the SG2 work under Capucin's area about what should we be recommending for how far away from your intended band of operation should you be defining? And once you reach that limit, what happens there? Is it HERF? Is it other aspects that need to be considered as well? So certainly it's going to be a long discussion, I think, when we reach that topic.
Yeah, a lot of challenges there. You mentioned, I guess, one parameter that I've noticed has been really hotly disputed in a lot of compatibility discussions between aviation systems and other systems like telecom systems. And that's the distance between that an aircraft could actually get, for instance, to a cellular tower. If the aviation industry and regulators can't come to agreement on that, it's really difficult to actually ensure safety of aircraft. Capucin, any ideas that have been discussed so far within subgroup 2 on how to develop a consensus on that and some of the other parameters that Andy mentioned?
Well, for separation distance, I think that could be one of the outputs that you will be able to withdraw from our methodology. So the idea is to consider the receiver and the transmitter as a whole system and not just focus either on the antenna or on the transceiver. So if you consider the system as a whole, you are able to provide an envelope mask. And then if you have both envelope mask and if you follow the methodology that we are willing to produce, then I think you will be able to have a kind of theoretical separation distance. You will, of course, have still some assumption. For example, we can mention far-field hypothesis for electromagnetics because we are not going to consider everything that's on the aircraft structure, for instance. So from a theoretical point of view, you will be able to retrieve minimum, at least a separation distance. But of course, it will stay a standard. So the actual performance of our CNS systems will be always better than the standard. So the reality will be a little bit better than what we will recommend. But that will be quite useful, at least for a new system, to check if they can be airborne in their current state or if they have some parameters that should be reworked. So that's still a good first clue.
Yeah, thank you. One thing you had mentioned, John, was on how we really have a disparity in the timeframes between telecom, where things can happen very abruptly, and in aviation, where our standards take a long time to develop. Do you have any thoughts on what we can do in the near term in order to improve what we're doing within RTCA and EUROCAE and aviation community at large?
Well, yes, Chris, actually, yes, standards do take a very long time to develop. We are getting better at it, but we are, in a sense, jumping on a bandwagon. Like spectrum standards is a long game. However, in order to sort of be better prepared for the next ITU study cycle, and I'll invite the audience to sort of have a look at the pre-recordings where we explain and explain the differences in the ITU cycles, what needs to be done between each cycle in order to sort of put a favorable case forward for aviation, but also determine the sort of studies that need to be made to understand what compatibility studies are needed. We're cognizant of all that, and we got to incorporate we started this group beginning of this year, so we are pretty much well established, but there's a lot of work ahead in terms of where we're sort of setting the crosshairs on. A couple of in our terms of references, we've got a couple of deliverables coming up next year, and one final one in 2024, as Capucine mentioned earlier. And we are trying to ensure that the community is prepared, geared up for the next study cycle. So we've got the World Radio Conference coming up in Dubai in November next year. So it's nigh under a year. And from then on, there will be the following study cycle, and they tend to come in 3 to 4 year cycles. We want to be able to produce and publish these documents in good enough time so that the conversations, the likes we're having, or we've been having these last several months and years with the IMT industry, with the radio radio altimeters, for instance, that we can empower those actors to have meaningful and also productive conversations when those conversations happen in be it, like I said, the ITU, CPT, or other regional groups. In terms of the structure and what we're trying to head for, the environment has changed, as I think I've labored the points during my presentation. So we're trying to ensure that when developers are looking at the radio specifications, the characteristics, they're looking more at things like, and I'll just bring one example out from the L-band. It's a very highly pulsed environment. We've got secondary radar systems there, ADS-B, we've got DME, all very highly pulsed. Throw in there in that mix an upcoming aviation data link communication system like LDAX, and what's happening also, not in our band, but in the nearby adjacent bands. They are spread spectrum systems. So we need to be able to specify, articulate protection criteria that protect pulse systems from non-pulsed or spread spectrum systems, and vice versa, something which wasn't in the previous environment. So these are the kind of things we'll be looking for in terms of content.
Yeah, thank you. And actually, related to some of the comments you just made on the importance of talking with the telecoms and others, as well as the cry that's been made a couple of times for additional spectrum experts within your group, have you had the regulators and other external stakeholders participating in SC 242 and 124, and if so, to what extent?
Look, we're not in a bad place. We like I said, we've had a sort of strong 45 membership. 45 organizations, most of which are quite active. We do have a few regulators among them. We have the USA, UK, France, Germany, and a few others. And that's great. We also have emerging users. We've got some folk from the RPAS and the drones sector is helping. And we don't have, as far as I can make out, any direct participation from telecoms companies, but I think there might be one. It's important to also specify that. And to the point I made earlier, we need more spectrum expertise in the sector at large. Most of us are around this table, be it on this side or in the audience. We need to make sure that we are kitted up and that there's enough resource, and which speaks to one of the points made yesterday by one of yesterday's panelists, that spectrum is getting a lot of attention also in high up management, which is very important, so that there's enough investment in this area. In terms of the expertise that we're using directly in the group, we are using in-house as it were contributors from those who are actually actively involved in this joint committee. But for what Andy said earlier on, we're also dishing out information and asking for information from other companion committees, those who are developing standards for specific systems. And we use a number of channels to get out of them. At the moment, we're preparing surveys. So the expertise is quite broadly spread. But I think in terms of, certainly back to your question, it's been we've had quite a good contribution so far, and I really do sincerely hope it's kept up. It would be really good to have more regulatory input so that we can test our documents as we go along in this development process. Back to you, Chris.
Yeah, thank you. I'm noticing we're at the end of time here. I'd like to thank very much all of our participants in this this panel, the leadership team from SC 242 and 124. And I'd also like to thank all the other members of those groups for all your contributions. This is certainly a very important role that you're playing for our industry, and we thank you very much for your time on these efforts. Anna, I'm not sure if you're with us now, but we'll hand back over to you. And thanks again for the audience for your attention.
I am. Thank you, Chris, and thank you to all of the panelists. This was again a very, very interesting discussion on, how we can adapt, how we can facilitate conversations within the committees, and how we can look at all of our standards and adapt them going forward into enabling better use of spectrum. Some great work going on in the committees, and I think from the Eureka and RTCA side, we can only echo Chris's thank you to all of the organizations that are involved already, and the call really to join. Just as a reminder, on the EventMobi platform, if you go to the companies tab, you will find information on how to join us there. Also, a reminder, you can submit questions for our panelists by going to the Q&A session of the main stage Day 2 tab and submit those questions for discussion, either in the panels, or if we don't get time to answer all of the questions, we will for sure follow up and do that after the event. So now, looking at our final session, we will look ahead a little bit. What's coming next? How can we work together on spectrum now that we have identified current and future environment that aviation is facing in utilizing spectrum for safety critical functions? This session will explore how we can work together to provide the best way forward. Our moderator is Eric Bouchard, who will discuss with experts from regulators, international organizations, and the industry the vision for future spectrum planning. Eric is a project manager in Dassault Aviation here in Paris, and has been the chair of the Eureka Technical Advisory Committee for many years now. Eric, over to you.
Thank you, Anna. So I'm very pleased to meet with all the guys of this session. So this session, working together spectrum, what's next? So we all know that working together now, after all what has been discussed, is not an option. So the main questions around this is how to make all the stakeholders around spectrum, users, regulators, and maybe others, to be able to find durable and balanced solutions. We need to address the very large scope of needs, scopes of issues, interests, what are the core values, and so on. So that's a large topic. And the question is, after in the end, what can be the relevant format in which everybody can tell what their view of the future is and how it may work. So it's a very large topic, framing the future. And so I leave the floor to our panelists. Thanks again for them to join. And I'll leave the floor first to Hette from EASA.
Thank you, Eric, and good morning to everyone. Good afternoon for those who are in Europe. So the theme of this session is working together. If we could move to the next slide, please. I'm going to repeat a few things I said yesterday. So for those who joined the session that I was in yesterday, you may see some overlap here, but we all know, and we've learned in the past 2 days, that spectrum is in high demand, and therefore it's a most valuable asset. We also learned that demand will only increase, and I do believe that, as an aviation industry, and I consider regulators as part of that industry, for all intents and purposes. We may not always appreciate the value of that spectrum that we are using. And I think it's important for us to start to realize that just that little, piece of radio altimeter spectrum that we're using is already worth billions. Now, that's not to say that aviation will have to pay for it. Far from that. But I think it does play a role in the sense that we need to manage our spectrum better than we do today. Aviation needs to become a good neighbor. And you may have heard Gary Bird in one of the earlier sessions today refer to ITU Radio Regulation 4.1, which in a nutshell requires us to apply the latest technology. The question that we could ask is, have we done that consistently? And can we do better there? I think in terms of being a good neighbor, we also need to be ready, or at least consider moving from the old dogmatic approach that we've had of protecting to sharing. We're never going to compromise on safety. That's absolutely clear. But the question is, can we use new technologies to enable safe coexistence of aviation and other spectrum use, either in neighboring bands or even in the same band? And I could ask a few other questions as well. Do we always need protection? Can we achieve the same thing by using redundancy, for example? And I also note that quite often we're using a lot of protected spectrum for aspects that may not always be considered as safety critical. So there again, I think we need to try to do better and have the discussions. Next slide, please. So I believe that spectrum needs to become part of our DNA. We currently discuss spectrum at quite a few levels, but it comes down, for aviation at least, to discussions that are being held in the ICAO FSMP, and those should continue, as well as the ITU, and in particular the World Radio Conference. But I think that we also need to foster more direct communications with other industries, broadcasting, mobile telephony, and state spectrum regulators. As an aviation regulator, I see that we left a gap there. We, EASA, should be having those discussions with the spectrum regulators in our member states. Again, going back to my good friend Gary Bird, he earlier stated that we should have government-industry partnership. But I do think that we also need industry partnerships. I've had, over the past couple of months, I've had a few discussions with the representatives from the mobile telephony industry, and it's actually quite interesting. I learned a lot there, and I think that we should be, we have common interest there, and I think that we should be reaching out to them more often than we currently do. Finally, and this circles really back to our RTCA and EUROCAE, we need to build and maintain expertise. I'm really glad that we've been able to establish EUROCAE Working Group 124 or RTCA Special Committee 242 on exactly this topic of spectrum. I think it's a great initiative. I think it's important for this group to support the ICAO FSMP and their discussions with the ITU, to support us as aviation regulators, and I think I speak for both EASA and our colleagues at the FAA, and finally to support discussions with or within other organizations. For example, discussions that the FAA is having with FCC and NTIA, discussions that we're having in Europe with CEPT. So I think the key message that I'd like to convey here is working together implies that we have to become good neighbors. We have to reach out to other industries. We have to reach out to spectrum regulators, and we need, in that way, to have a more common discussion, more common platform we should all be at the same level, and I hope that we'll be achieving this in the next couple of years. Thank you very much.
Thank you very much, Heta. So I think now I can hand over to Don from Honeywell.
Yes, thank you, Eric. I'd like to focus my presentation here on, reflecting back, especially on the painful experience we had with radar altimeters and the 5G issue, and just challenge the industry in saying, is this a one-time event, or is this going to happen over and over again as we go forward? And I think we've heard through these different sessions that spectrum is going to be a continuing challenge. So I believe it's Albert Einstein who said insanity is doing the same thing over and over, expecting different results. So working together, what should we do different? How can we change our approach? So I broke this down into two aspects. One, how do we work with others outside of the aviation industry? And I think there's two important aspects to that. The first is getting earlier insight. Other panels have discussed getting earlier insights. I equate this to what the coal miners did when they would take canaries with them, to make sure they could, if the canary died, there was some bad air in the mine, and you better take some evasive action. So maybe we need aviation canaries to be sitting in some of the regional, national, state spectrum policymaker, regulator organizations, track what they're doing, and maybe in some cases really actively participate and provide real-time feedback. But who can do this? And maybe I would challenge that our international, regional, and national aviation associations and some of the regulatory authorities, maybe they could step up to do this. I don't think certainly the airlines or the OEMs or equipment manufacturers probably don't have the bandwidth to do this, but maybe that's an activity that our associations could step up and perform for us. So it's a thought, who would be in a good position to do that. But once we get that early identification, then we as an industry need to be ready to better educate those outside of our industry about the impacts of the pending action on our industry. And I think so often, again, reflecting back on the 5G case, I think the engineers, the technologists, the scientists knew for several years in some of the standards developing organizations that the 5G issue was going to be a problem. But I would challenge us to think about how many times have we heard that industry executives were surprised. They didn't know about this, until it hit the Wall Street Journal or the New York Times or the mainstream media, and they were. I challenge all of us to think back. How many times did executives in our different organizations come back and say, well, why wasn't I aware of this? So I think we owe ourselves to have the engineers, pull themselves out of the decibels and the spectrum masks and all the other things that go into a 100, 200, 300 page standard, and we have to be able to abstract it up several layers until we get it simple, and as simple as perhaps having a one-page infographic that explains, what are the safety implications, what are the timeline implications, what are the costs involved, something that can be explained to executive level folks, our elected representatives in our various, legislatures around the world, the regulators in the spectrum, who aren't familiar with aviation specific spectrum issues. And of course, then, once you can get their attention with a one-page infographic, then you can go into, short white papers to help continue to educate them. And then finally, perhaps press releases in the, in not only the industry media, but also the mainstream media. If, something like RadAlt 5G probably warrants, getting the court of public opinion to be thinking what we're doing. And I think we all know in the industry how long our aviation specific regulation timelines take to develop new standards, and then once you have a new standard, to develop new products, and then for the airspace users to actually buy, equip, and train to use those new products. So I think we need to explain that in very clear terms to others outside of our industry. Perhaps if we can educate them early, and before the spectrum regulators decide to auction or license some spectrum off, if we can make those costs to mitigate clearly understood, that perhaps as part of that license revenue, or there can be some discussion about how is our impacted industry, how are we going to be made whole, because we expect our products to be in use for decades, and no intent to replace a perfectly good working piece of avionics with something new or something to mitigate the new spectrum user coming on board. So I think having those kinds of information would be really important, and to get them out quickly. And I think we need to inform and lobby spectrum policymakers, regulators, and non-aviation spectrum users. We need to educate them through multiple paths. When you have a complex topic to discuss, you shouldn't just say it once and hope they understand. Pick different ways, like the infographics or the white papers or media press releases. Find multiple vehicles to educate them, and educate them frequently and repeatedly, because it may take some of these audiences some time to understand, and hearing multiple ways and in multiple formats, the impacts to our aviation industry. They're not as steeped. Many of us have decades of experience and we understand this, but it's very new to some of these other folks. And then finally, we should educate until we know that they understand. So we should be looking for some acknowledgement that at least they understand our position. Whether or not they agree with it is a different topic, but we should continue to educate them until we're sure they understand all our points and all the impacts that we're addressing. So next slide, please. So then what do we need to do as what would we do differently working together within the aviation industry? I would propose, and leave it for thought for some of our associations, that we need a clearinghouse. We can't rely on our semi-annual, quarterly get-togethers in standards development organizations or policy meetings, things like that. We need to have a much faster approach to disseminate information, those aviation canaries in the mail, in the mine. Have those canaries, report out and alarm that there's something, and we need a clearinghouse for where that information can be presented to the aviation industry. And then we can, we should be developing, as we know those actions are coming, then we need to, develop aviation industry positions. And I think, again, reflecting back on the 5G situation with the RADALs, I think we would all agree that maybe the aviation regulators in the industry didn't come together as quickly as they could have. And so what do we need to do differently there? This is not only for our legacy systems that are out there and on our equipped aircraft out there, but think of all the new entrants. Think of UAS, UAM, RPAS, air taxis. Are they going to be having new spectrum requirements? And agreed, like I agree with others who have said, we need to use the spectrum more efficiently. Well, we could certainly start doing that with the new entrants if they're not going to be relying on some of the old spectrum and the old protocols and communications protocols and what have you. So, we can certainly look at those new entrants, and within the industry, quickly, bubble up into a clearinghouse, what new spectrum requirements are coming out there from our own industry. And then we also need to look, I think others panels have said, about the impact on automation. So as we're moving to more and more automation, and maybe less reliant on the human in the loop or on the loop, these spectrum issues are going to be really important. So maybe in the early days, maybe a radar altimeter just gave a height above terrain, to the pilot. But I think nowadays, we heard in previous panels, and we learned in the 5G rad-alt case that radar altimeter is tied into many systems on the aircraft. So, do we truly understand that even amongst ourselves, how all these different spectrum using avionics, how that is integrated into all the automation that goes into these, and do we really know the impact on our industry's operations? So, as I said on the previous slide, I think we as a group need to have a clearinghouse or a storehouse for infographics that, for instance, maybe on the 5G rad-alt, we already developed, maybe some good talking points about our, what our regulations are like, what our product life cycle is like, what our costs are, what's the volume of avionics out there that make use of this spectrum or ground systems. And, we could probably bring those infographics and have them, refined and really get them honed down to where when a new issue comes up, we would have some ready-made infographics and white papers to initially start educating others outside of our industry on the impacts, and then develop the more pointed infographics, white papers for the particular issue that's coming up. But at least we can start to get that high-level education out there to other industries. And then I think we collectively as an industry could probably do a better job of collecting best practices for engaging with spectrum policymakers, regulators, and non-aviation spectrum users. So, what went well, in the 5G, case, what didn't go so well, and let's keep a repository or a collaboration site someplace, some aviation industry association, set up a clearinghouse where we can keep all those best practices. And then finally, I think that can be across a couple dimensions. That can be across policy, that can be across regulation, and that can be across standards development. So, so we need to think of not only as as we often do, the technical issues at like a standards developing organization level, but we very quickly need to get it out of that realm and get it into the realm of influencing other spectrum regulators and policymakers and the court of public opinion. So, to summarize here, I think we need to identify early. As an industry, we need to coalesce quickly around a common position, and then we need to defend mightily with other stakeholders outside of our industry. We need to defend our position mightily and make sure we're heard and understood. With that, thank you, and back to Eric.
Okay, thank you, Don. So in order to have a bit of time left for the question in the end, I'll hand over to Pascal. Pascal, are you with us?
Sorry, my sound was off. Hello to everyone. My name is Pascal Luciani. I'm the Deputy Director for Air Navigation and Aviation Safety at the Air Navigation Bureau of ICAO. And as such, we are very much concerned with this issue. And it's one of the major risks that we identify for the future of aviation, and a question that needs to be addressed. So if we can go to the next slide. I was very much awed by the debates that we had during the RTCA EUROK sessions, and the fact that there is a common vision that is emerging. We all are coming here with different perspectives, but we are sharing a common vision. And I will have a spoiler alert on my presentation. It will be very much in line with all the other presentations. And I think that a new vision is emerging. Probably in a way, the 5G controversy, as nerve-wracking as it was, as worrying as it was the catalyst for a change and for finally going forward. And I would say that from ICAO's perspective, from the point of view of an international organization, the two main messages that we have now is the two key concepts of an argument based on an argument-based defense of the spectrum and efficiency improvement, which is very much in line with what I have heard before. And I believe, to answer Don's question, no one wants to live the 5G crisis again. So next slide, please. The defense of the spectrum. Yes, it must be based on explanation and further explanation and anticipation. The basic assumption we must have is that there is no member state that is going to willingly endanger aviation safety, even to make a couple of billion of dollars in fees. So it's not the will that we're up against. This is not a fight of wills. This is a fight of information. What we must do is provide timely information, clear information, structured information, and anticipate as we go. Because just as I know member states none of them are willing to endanger aviation safety, no private operator is somewhere planning to say, oh, we'll build a great concept, make a lot of money based on endangering aviation safety. If they know it's not safe, they'll try to find ways around. So how do we work on that goodwill basic assumption? ICAO, as ICAO, we can provide a platform for a common message for a harmonized usage of frequency. Frequency spectrum is harmonized worldwide, and the solution will be worldwide. However, the work does not stop at ICAO, and each and every single member state will need to be vocal about the common message we have, will have to word it out in the various forum when they're interacting, will have to interact with other actors in the country, in their country and international forums, and will have to work with ITU to move forward. We received at the assembly, the 41st assembly in September and October, a very strong mandate. And this mandate in resolution 41.7 urges member states to consider as a priority public and aviation safety on spectrum matters. This is something that for which I'm turning back to the member states. Help us deliver this message. And finally, in this arguments-based explanation, we can do nothing without the collaboration of our partners of ITU. It will be instrumental. We know that they are partners. We know that they are very willing to listen to us, but we have to provide the information and give them the input they need to move forward. So this is how we defend the spectrum. Next slide, please. Now, if we are going to be successful, the right to have our spectrum protected implies a duty to resolutely implement efficiency. We are going to be credible, we are going to be followed if we're efficient. And this is a message I've heard throughout the interventions of the last 2 days, and I couldn't be happier for that. In fact, the Assembly resolution A41.7 doesn't start with let's defend the spectrum. It starts with a commitment to deliver spectrum efficient aeronautical frequency management that meet current best practices. This is something that we must work into. One of the projects that is being initiated in ICAO is the Integrated CNS Spectrum, ICNSS initiative, which is a way forward and which will capitalize on what was mentioned before, especially working on redundancies, working on overlaps, and making sure that the system as a whole is made safer. We need to have a better understanding of the interactions at the border of frequencies. Never before were we so much challenged at the border of the frequencies. And this probably means that our knowledge, our realm of knowledge has to increase, and we have to work on this proactively. And finally, what we must work on is better resilience as a result of innovation. We cannot simply rely on saying we need a completely blank frequencies on either side of our frequencies to be safe. We need to work so that we attain resilience and that we are better able to cope with the incidents that will happen, and that we're better able to shift to other ways to achieve the same results. This innovation will, of course, not be brought up by ICAO itself, but through the collaboration of everyone. So this is, in a sense, the two messages I wanted to give. We have to defend ourselves, but we're not up against enemies. We're up with people who need our explanations to move forward. And if we want to get results, we have to show. We should not paint a target on our backs by not having improved. We must, on the contrary, show that we're leading the way, and that will get us to be followed by the rest of the member states and the aeronautical sector, because we share the common interests. Thank you very much.
Very good. Thank you, Pascal. So now hand over to Olivier from Airbus.
Thank you, Eric. Thank you. Good morning, good afternoon, everyone. Okay, first I would like to thank RTCA and ROCAI for the invitation to participate to this panel, which is a very good opportunity to share views and feelings about the spectrum. Unfortunately, it's the last panel. I will not be very innovative, in fact, because everything has already been said, and I will reiterate the same purpose. What is good in this situation is that we are almost all the same view, and in the future we can expect a very beneficial cooperation and coordination between us, just to defend our spectrum. So, of course, spectrum is key for aviation. I think it is quite obvious, but as well as for other communities. We can just say, yes, the aviation needs a spectrum. If there's no spectrum, there is no CNS, no interoperability, no aircraft, no business. But I would say that this is almost the same for the mobile community, because we talked a lot about the mobile community, but also for other radio community. So in the course of the different interventions, I noted that during this summit, that I heard several times that aviation is not so much involved or present in a spectrum regulation forum, and also during the debates. Unfortunately, I have to admit this. I tend to agree on that situation. We can only observe that when we are looking at a dedicated forum or organization for in terms of a spectrum regulation, so international level in ITU or regional level in CPT, for example. There is other, of course, regional organization, but at least even if we are looking at ITU and CPT, where spectrum regulation is discussed, we can just observe that the aviation community is not well represented, and even if spectrum is key in different respects, and even if we have many stakeholders, because dedicated to aviation, there is authorities, there is industry, there are also airlines, and many other actors and stakeholders. So we have a high number with a lot of benefit, a lot of interest for spectrum. But at the end, what we can see is that in ITU, CPT, and other forum, there's not a lot of participation. So of course, there is a fact, and this fact is the aviation's benefits from a non-comparable advantage, which is a dedicated and protected spectrum. Yes, of course, there is some requirements. There is safety requirements, of course, and we could say that such considerations in terms of spectrum, dedicated and protected, is a must in terms of spectrum planning, spectrum coordination, and spectrum management. Is a must, but it is also a great advantage, because we need to deal with our own application, our own spectrum, and so on. So I will not say that this is an easy approach, but at least this facilitates our work in terms of spectrum. There is also one thing which has been pointed out in different intervention, and I heard that we are speaking with our own language. We have our own constraints and own requirements, of course, which are from aviation regulation, for example. But we have also common objectives and in fact, at the end, limited external challenges, except in the case where we have to deal with a different neighbor. But at least in the band itself, we are inside within one community, which is the aviation community. So this is a constant, and this is the reason why there is this point is pointed out that the aviation community is quite isolated and focus on the aviation purpose. Today, there is one observation we could be made is that almost all the aviation spectrum, the dedicated spectrum, is below 6 gigahertz. So 20 years ago, the golden band was below 1 gigahertz. But today, in front of the technology improvements and the different radio systems and new technology and new innovations, we can see we can say today that the 6 gigahertz, below 6 gigahertz, we can talk about golden bands. So which means that there is a very high pressure on the usage of this band. And if we make the parallel, for example, with 5G and the different part of the spectrum, this spectrum, which is below 6 gigahertz, encompasses two needs for 5G, which is the coverage below 6 gigahertz, and also a mid spectrum, which is able to offer high data rate and also some capacity. So just to say that with regard to this spectrum, which is quite, I will not say congested, but very occupied, I would say. But the demand is very high because it can cope with different needs for different proponents and different industries. Therefore, the least spectrum gap is a waste of spectrum that everybody could see as a usable resource, which means that we can be challenged every time if our own only protection is a spectrum gap, for example. So this is, I would say, quite provocative, and in red it's more provocative yet. But today there is a need just to defend our spectrum, and for that, I think that there is a need also to look at and to communicate and to exchange information with other spectrum users, because of course we have a main focus on the aviation domain. There is some authority, there are some regulation, but we are also depending on the spectrum regulation, and therefore in that context there is a need to be more involved in this debate and to take part on the discussions, and especially when our spectrum is challenged. In fact, the spectrum is a natural resource, which is managed by spectrum regulators for the benefits of everyone. So there is a need to accommodate all the need. So of course, when we look at ITU, for example, I would say that the basic rules is a compromise, but as already said, of course, safety cannot be subject to compromise. So we need to manage this dilemma, and we need also to ensure the correct protection for our safety applications. For that, we need to anticipate, to share information, and also to show some transparencies about our systems, how it works, how these systems could be protected in terms of interference criteria, and so on. So there is a strong need for more engagement in spectrum regulation, and also to participate to the debate, to share, to educate ourselves on spectrum, because there is a need, as mentioned previously. The radio altimeters discussion started with some misunderstanding about the wording which is used by both parties, but also there is a need to explain a little bit and to discuss about aviation needs, what are our requirements also, and our constraints to operate quite safely.
Okay.
So there is this. Next slide, please. So of course, the race is quite different because on one side,
Olivier, can you please wrap up quickly now so that Nicolas
yes.
has the time to talk?
Yes, this is a conclusion. So there is a strong a race which is quite different. On one side, we have the mobile, for example, but it's not the only community, but they can spend billions to gain access to spectrum. And there is also, I would say, applications which could answer to many domains. So it's quite attractive. And other needs on our side, we need to be to cope with our own need, and then we need to be committed and unified. I would say that the working together is quite obvious. So with all authorities, we used to discuss with aviation authorities, but there is also a need to extend this discussion with other authorities, and spectrum authorities is already key for the spectrum, of course. And one point, which is related to the industry, there is also a need to discuss and to coordinate ourselves in terms of industry. Who represent aviation interests today? Today, there are, for other committee, we have the GSOA, we have the HCA, GSMA, GSA, SEA for satellite, mobile, car industry, okay. But for aviation, who is the association who defend and represent the aviation industry? So this is an open question, and I think this could be, this could help us at least to be unified, to talk with one voice, and to defend our interest in the spectrum regulation and spectrum 4. Thank you.
Thank you, Olivier. Nicolas, I leave the floor from ITU. I leave the floor to you.
Thank you very much, Eric. Next slide, please. Just before going to any advice, maybe it's useful to identify who are the main spectrum players. And from this point of view, you know that spectrum allocations and regulations, how to use this spectrum, are established in the ITU. These allocations and the international rules are decided at World Radio Communication conferences. They take place every 4 years, and the results reflected in the ITU radio regulations. Very important document because it has the status of international treaty ratified by the governments and mandatory for application in the countries. Then these ITU rules, international rules, are translated into national regulations, and here the responsibility goes to national telecom regulator. They have quite a significant degree of freedom in regulation on the condition that they don't cause interference to neighboring countries. Then we have also heavy weight player in spectrum, which is ICAO with all its functions, and civil aviation authorities. And this gives us the list of spectrum players with regulatory functions. I would like also to mention that currently aviation has very good spectrum. In many cases, your allocations are exclusive. They are global, and this allows to provide the interoperability in the global scale. They are large and valuable bands, and this explains why they're so attractive for other users. And aviation spectrum is very well protected in the ITU radio regulations. So you're very important, you're a privileged user, but you're not alone. There are 42 radio communication services in the ITU radio regulations, all require spectrum, science, governmental, mobile, broadcasting, and there are industries behind these communities. So I put these stakeholders on the right side of the screen, so you may need to talk to everybody. Spectrum regulators and spectrum users. Next slide, please. And then how to improve the situation. From my point of view, there are two main directions. First is good planning for future, and the second is more collaboration. Good planning for future implies that aviation protect well its current spectrum. And practical advice here, please just check frequency requirements for newcomers, especially from mobile community, and everything available in the agendas of World Radio Communication Conference, sometimes even 8 years in advance. And then when you identify the requirements, please assess impact on aviation. With special attention to adjacent band and radio altimeter situation proves that this is very important, adjacent band compatibility. And the second direction is, or element, it's advanced planning for future aviation requirements. Your technologies are evolving, so you will need certainly new frequencies. It's good to identify them earlier. Practice shows that 8 or 10 years in advance before the conference, it's good time slot. And then start to explain your needs to other stakeholders, especially who are affected. Persuade, convince, charm these communities. And finally, just to repeat what other panelists said, that you may need more collaboration. Make friends with telecom regulator. They're very powerful players. Participate in ITU studies at all 3 levels. National level, speak to your national regulator, telecom, and your other spectrum users. Regional organization, there are 6 of them for different regions of the world. And the importance weight is growing. At the conference, they're making decisions there. And internationally, please come to ITU, participate in ITU studies, to put in recommendations your parameters, your protection needs, the ways how to share spectrum with others. Raise awareness, it means you explain the importance of your bands and your requirements to all other spectrum players, and disseminate, of course, best practices among your community. Here, I would just to recognize the very important and always increasing role of ICAO, its regional offices, and frequency spectrum management panel, doing great job. Thank you, Eric.
Thank you very much, Nikolai. So we reached the end of the slot. I'm afraid we don't have very much time for questions, do we? Okay, thank you, Anna. So maybe I would like to ask one question to you, which is, Heather mentioned the initiative of RTCA Special Committee and the EUROK Working Group. What would be your views about the role that EUROK and RTCA can play in framing this way forward? So maybe Nikolai, as you have the floor, first, if you have some thoughts about that.
I would give the floor to other colleagues. We are quite away from these two. Sorry about it.
No, no problem, no problem. Heta, maybe your views about that?
Yeah, I would think, first of all, a center of excellence. I think it's a good opportunity to bring the experts on spectrum that we have in the industry and with regulators together. And the second role that I think this community could play is perhaps, and I refer to what Don said, being that canary in the spectrum mine. And alert the community as early as they understand that there may be an issue.
Okay, thank you, Heta. Maybe Pascal from ICAO, an idea about that?
Well, from the point of view of ICAO, this is something we cannot do alone. And we have very, very strong partners with RTCA and EUROK. They have the ability to mobilize resources. They're credited. They have big credit, and I believe that they can be the bulk for a creation of the expertise we were calling for. Once again, the knowledge is going to be the key. This is something I really believe in. And if we can build this knowledge, things will be much easier than we anticipate, and we will probably not need to be fighting as much. So we would really like to turn to you to develop this in collaboration with your partners. So I can only be in favor of this.
Okay. Thank you, Pascal. Interesting. So maybe it's time that we stop. I have plenty of questions I could ask, but I'm afraid that we must stop here. Thank you very much to all of you. And Anna, I hand over to you now.
Thank you, Eric, and thank you to all of the panelists. Wow, this was another great session, and it's I think we could continue the discussion for hours and hours on this and on all of the other panels. I really enjoyed the entire event, and I hope so did all of you. So over these 2 days, we've had 6 sessions of really high value. I hope you enjoyed it as much as I did. Certainly, I learned a lot. We took a look at challenges facing in this increasingly scarce resource. It is both safety critical to aviation, business critical to telecoms, to aviation as well, and how we can actually work together. We've seen that spectrum as a valuable resource. There's lots of competition for its use. Aviation has applied so far a rather conventional approach to spectrum, but we maybe need to rethink that a little bit. We need more interaction across industries that formerly did not talk so much between them. Coordination between government and the industry is important, as well as industry-industry partnerships to make it happen. We also saw that spectrum is a global issue and needs a global response. So the outreach to other regions, such as we had yesterday, a colleague from Japan on the panel, is really important. And ICAO for sure has a role in this to play as the global organization for aviation. We saw that the optimization of the systems together between aviation and the telecoms industry, taking into account the safety and security standards required for aviation, is possible, it's happening, it takes time. There's a vision, but we need some revolution and some evolution to get to that and to implement that vision. We need to learn maybe from other examples, leverage experience from other industries. We saw the GA case yesterday, general aviation, UAS, the whole AAM sector, how it moves forward. So that we learn from those, how we can go quicker, but never compromising safety, of course. Overall, I think we've seen it takes time. Aviation takes time, safety takes time, but if we all work together, we can actually make it happen. It's happening today already. The coexistence between aviation and 5G is not only possible, it's happening today. We are getting better, we're accelerating, especially with the advent of new technology. Working Group 124, SE242, RTCA, EUROCAE, I think are recognized as knowledge sources, centers of expertise, and facilitators on how we are getting there. But those are just a few takeaways from me. I think Terry's on the line with me. Terry, what are your main takeaways? What do we as standardizers have to do? What can we do? What can we contribute to show that aviation is a good guardian of the spectrum that we have, and how we can improve going forward?
Well, thanks, Anna. And first, again, my thanks to all the panelists. Another great set of panels and panelists today. I was also thinking about, our vision for this event. We developed over a year ago at our yearly EUROCAE RTCA coordination meeting. So it's great to have this event come to fruition, and great work by both of our staffs and pulling it all together. I probably won't say anything that hasn't been said at least once or twice the last 2 days, but kind of condensing maybe 3 points in my mind that I think are relevant to the discussions. First, we sometimes get criticized for the slow pace that standards organization operate at, and but it's also clear that we have to make sure that what we do develop, those standards are both technically sound and operationally ready for both the industry and the regulators, so that they can serve as that basis for both the design, the build, as well as the certification down the road. And the importance of applying this to future spectrum allocations and that impact on aviation really can't be overstated. As we've heard, and it's been argued that aviation hasn't been good stewards of the spectrum we've been allocated. Fair criticism, but then again, we haven't had to be good stewards because there wasn't a lot of competition or other usage applications near the bands we had. But those days are over. And what we've experienced with C-band 5G rollout, has been said several times this morning, really is just the tip of the iceberg. And that's why I'm so proud of the work that SC242 and Working Group 124 is doing, because it's both evaluating our current systems to see where we may need to enhance our standards, current standards, so that we can be better guardians of what we have. But just as importantly, it's forward-looking, so that we can serve as that forum for discussing with industry, discussing with the regulators those future allocations of spectrum and how it's going to be, and how that's going to impact those future needs. My second point really is about the collaboration piece. It's again something we've heard a lot about over the last couple of days. And of course, collaboration is really one of the foundational elements about both how RTCA and EUROCAE operate. But we also have to think about expanding that collaboration to some of the other tangential industries that will be utilizing the spectrum. Telecom is obviously the one on our minds today, but there's going to be others. But it's just as important that those other industries have to be willing to roll up their sleeves and work with us too. So there's so much that we have to learn from each other, and it's going to take both of us to come to the table. And my last point, I guess, is kind of how do we bring my first 2 points together? I'm a firm believer that standards need to be seen as an enabler of innovation and new technologies, not a detriment to innovation. Standards are the means to bring a lot of the work in R&D into the implementation and integration modes. So standards give that industry the roadmap to design and build to, and then for the regulators to use as tools, to use as the basis of certification. But without that collaboration across aviation and those other tangential industries, success is going to be difficult for everyone. And so great event, I think. We had a lot of perspectives on the table the last couple of days that really touched on all of these points. And I think our challenge now is to keep this momentum going forward and continue to build on what we've done so far. So thank you, Anna. Great job today. And we'll keep it moving.
Thanks, Terry. I couldn't agree more with your conclusions, especially on the last item in terms of collaboration and in terms of bringing the standards forward. And we can only reiterate the invitation to both the aviation, but also the telecommunications communities to join these efforts within Working Group 124, SC242. Look at the companies tab on EventMobi or email us if you'd like to get involved, please. This is really a chance to all work together as we've all heard so much over the last 2 days. So just wrapping up, look at the EventMobi platform. If you'd like a copy of the slides from today's sessions, please email us at membership@rtca.org. Questions that were not answered in the sessions will be shared with the panelists, and a Q&A sheet will be available afterwards as a follow-up on the event via our websites. The links will be made available by our colleagues. Today's broadcast will be made available on the main stage day 2 on EventMobi. Yesterday's broadcast is already there, and also don't forget there's the overview session, this 26 minutes overview, which is a really well done short video. Please don't forget to give us your feedback on the event. We'd really like to hear what was good, what we can do better, and also what kind of topics you would like to hear from us in the future. So please visit the polls and surveys tab to answer a very short survey, and I promise it will only take a few minutes, but it will help us improve a lot in the future. Thank you to the sponsors for this event, the Airline Pilots Association and Garmin. We really appreciate your support on this. A big thanks to the entire EUROCAI and RTCA teams who have prepared this event for us and to make everything go very smooth and effortless. There's a lot of work that went into this, so thank you very much to all of you. And thanks again to all of the speakers, moderators, and to all of the attendees for the great sessions, the interaction, the participation, the great questions. We really hope to see you in our working groups and at future events, and hope you enjoyed this as much as I did. And with that, I would like to close this year's Global Aviation Spectrum Summit as a joint EUROCAI and RTCA event, and wish you all the best and happy holidays.